morning, everyone. Thank you for joining us on this webinar on using find operations with structured text. It's a relatively short one. It's about a 15-minute overview, and if you have any questions, we can get to them then.
Hello and welcome to today's webinar. Today, we will look at find operations using structured text. Let's look at our agenda for today. First, we will discuss some examples where finding a value in a list of data can be useful. We will then look at some user-defined function blocks that we can use in our program to do this. We will also look at how to use these UDFBs in structured text. There will be demonstrations throughout, and we will finish with the Q&A session. We will first look at some applications where it would be useful to search through a list for a specific value and get returned an index for where in that list the value has been found. We will look at an example for an array of part numbers. Let's say that we have a machine that is managing a set of tools, and for every tool that we are storing and retrieving, there are a number of parameters for it, such as a part number, as well as the length, width, height, and weight of the tool. Each of these parameters may be located in a separate array of data, but these arrays are all correlated as they have the same indexes. So if a tool's part number is listed as the fifth element in the part number array with an index of 4, the tool's length, width, height, and weight will also have an index of 5 in their respective arrays. So searching through a list for a specific part value would allow us to retrieve similar information from different arrays for the same part. In the latter screenshot shown, we can see how we would do this using a user-defined function block. Here we are performing a data find operation, where we are looking for a specific integer value that represents a part number from an array of data. Once we find this value, which is the index of the part number in this example, and in this case an index of 36, then we use this index to find the corresponding length, width, height, and weight values. A find character UDFB can also be useful in an application where we are reading in barcode data as a string of characters, and we need to find a specific character in that string that points at a data field that we want to parse from that barcode. So in this case, we would be searching through an array of characters for a specific character. Next, we will look at some of the user-defined function blocks that will allow us to perform these data find operations in our applications. These are listed in the box shown. The first 4 functions allow you to search through an array for a specific value and can be used depending on the type of data in the array you are searching through. The first function can be used for a short integer or a byte. The second can be used for integers. The third can be used for double integers, and the fourth can be used for real values. The last UDFB in this list allows us to find a character from an array of characters. Now we will look at how we can use these UDFBs in structured text. To use a UDFB in our program, we first have to import the necessary files into our project. To do this in Cscape, we go to the Project Navigator section and right-click the Logic Modules entry in our project tree, and then we select Import Logic Module. From there, we can navigate to the folder containing the UDFB files we want to use. Once these are imported into our project, they will appear under the UDFB modules in the project tree. Next, we need to create instances of these UDFBs for each case where we want to add one of these UDFBs in our logic. We can do this in the Program Variable window. So if we only need to use a particular UDFB once in a project, we only need to create one instance of that UDFB. We also need to make sure that we give this instance a unique name to the UDFB and make the type the same as the name of the UDFB. This is because once we have imported a UDFB into our project, it appears under the pull-down list of all the different types. Next, we will look at the specific inputs and outputs we would use with our 4 data find UDFBs. Each of these UDFBs has an enable input. This needs to be turned on in order for the UDFB to function and should be left on until we have the results we are looking for. The next input is the target value. This is the specific data value we are searching for. The type of value we are searching for will depend on whether we are looking for a short integer, an integer, a double integer, or a real number or floating point. However, the name of this variable is the same, regardless of which of these four UDFBs we use. Our third input is the first input of the variable array to be searched. This can be an integer, short integer, or double integer, depending on the UDFB you use. Our last input is the last index variable, which is a double integer value and represents the last index number for the particular array you're searching through. These functions have the capability to search an array of up to 1000 elements. So if we have an array with up to 50 elements, then we don't need our function to search through 1000 elements, so we would set the last index to 49 and stop searching once it reaches the 50th element. This acts as a safeguard to prevent the execution of a program where you could be searching beyond the end of an array variable. These functions also have three outputs. We have a done output, which will turn on when the UDFB is complete with its operation. We also have a value index output, which tells the index of the first instance of where our target variable was found. If we don't find our value, then this will return a -1. Finally, we have an error bit that will turn on if we are trying to search through an array greater than 999 elements. We will also look at the specific inputs and outputs for the find character UDFB. Once again, we will use this function to search through an array of characters or an array of unsigned short integers, which is how standard IEC and Cscape handle strings. This UDFB has four inputs. Similar to the previous UDFBs we looked at, this UDFB also has an enable input. This input only executes on the leading edge. However, it should be turned on and left on until we are done with the function block. We also have an input array, which is an array of short integers, which represents characters. Next, we have the last position variable, which is the last position in the array that we want to search. This position is one-based, meaning we need to specify the last position we want to search, not the index. Finally, we have a variable called character, which is the ASCII value of the character we are looking for. Once again, we have an error output, as well as the result, which is the one-base position of the character we are looking for. Next, we will look at how we will use these UDFBs in structured text. First, we will look at the syntax to do a function call with the find character UDFB. First, we have the name of the UDFB, followed by our four inputs in round brackets and separated by commas. On the second and third line, we have two outputs, which we access using assignment statements. To the left of the assignment statement, we have variable names for the variables that we will be copying the output into. We then have the assignment statement, followed by the name of the UDFB, and then the output name after a dot. Now we will look at how we would actually code this UDFB. Instead of doing a function call using the name of the UDFB itself, we are using the name of an instance of the UDFB. So if we are using the find character UDFB, we would first have to create an instance of the find character UDFB, which we have named findCR in the example shown. Following this, we have our four input variables in round brackets and separated by commas. We have given these inputs and outputs different names to those seen in the syntax. Below this, we have the two assignment statements that we will use to retrieve the ERR and character position outputs into the variables error and CR position. Now let's look at our example program to demonstrate these UDFBs in Cscape. First, we need to import the UDFB files we want to use in our project. To do this, we go to our project navigator and right-click on Logic Modules. Then we select Import Logic Modules And from there we can navigate to the folder that contains the UDFBs we want to use and import them one by one. Once they are imported into our project, they will appear under UDFB modules. Before we can use these in our project, we need to create instances of the UDFB for each time we want to use it in our program. We can do this in our program variable list. Here we have created one instance for each of these UDFBs that we imported. Here we can note that every instance that we create must have a unique name. Let's look at the first instance we have created, which we have named testFind short integer. We have set the type for this instance as the name of the UDFB, so once we have imported a UDFB into our program, it will appear in the list of type names. We have also made instances in the same way for the integer, double integer, and real number UDFBs. Now let's look at an example of the coding we may use to find a specific value of a short integer from an array of short integers. Here we have our function call, which matches the instance name for the function block we want to call. Then we have our input variable names inside round brackets and separated by commas. In this example, we are retrieving 3 outputs from the UDFB using assignment statements, and then copying those done, ERR, and index value outputs over to other variables we have created in our program variable window. We are using the same syntax for the short integer, double integer, and real versions of those UDFBs. We will also take a look at how we have coded the find character UDFB. On the first line, we have our function call with the name of the instance we created of the type of the UDFB that we imported. If we hover the mouse over the instance name, we will get a tooltip with the details of the inputs and outputs of our UDFB function. In the second and third line of our code, we are using assignment statements to retrieve output values. In this case, these are the ERR output and the CR position output. Now let's look at our bench setup for this demonstration. First, we will do a data search through an array of short integers. In the center of our OCS screen, we have a list of 5 values from an array that could be as large as 1000 data values long. These have indexes 0 to 4. We also have an enable button on the left, which will enable our function and find the data value we are looking for when we press it. Below this is the last index we will check in our array. So even though we could have up to 1000 elements in an array to search from, if the array has a maximum index of 31, indicating there are 32 elements in the array, then we want the last index to be checked to be equal to the last index number. This is in case we don't find the value we are looking for when we get to the end of the array, and will prevent us from going through the loop indefinitely. Instead, we will be returned a value that will indicate that we have not found the value we are looking for. On the right of our screen, we will have the output result once we run our UDFB. We also have our done and error bits. Now we will execute our function. We have been returned an index result of 2, which means the third element in our array is where we found our target, which was 57. So the first value of 57 our function has found has an index of 2. We can see that there is another 57 at index 4. However, our function did not return a 4. This is because these UDFBs always return the first instance of the target data they are looking for. Our functions for integers, double integers, and real values work in the same way. We will demonstrate these next. We will change to our integer function screen, where we are searching for a value of 745. Once again, we are able to find this on our list, with an index of 2. Now let's look for a value that isn't on the list. When we execute our function again, we get an index value of -1. Next, we will look at our double integer screen and search for a value of 99,999. This returns an index of 4. We can also see that our done bit turns on. Once we turn off our enable button, this bit turns off and our index result goes back to 0. Finally, we will change to our floating point version of our function and search for the value 1.9. This is found as the fourth element in our array, so we are returned an index of 3. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, nice and straightforward, I hope. Again, you'll be able to watch this back on the webinar section of the website. It'll be uploaded in the next day or so. I'm not seeing any questions in on that just yet. Okay, I think that seems to be it. We'll see you again next week at the same time. Thank you very much.